So let's move on to the next bullet point. Remember, know how to identify the atomic number, atomic mass, number of protons, chemical symbol, chemical name, and number of neutrons. All right, so really quick, remember right here that the atomic number is this number right here, right? And the definition of the atomic number is the number of protons inside of an atom, right? So in this case, there are 86 protons in radon. But if you know this, and then you know that you also have 86 electrons, right? So again, if it's a neutral, if it's not a positive or negatively charged atom, it's going to have the same number of protons as electrons. So again, 86 electrons. And then in most cases, you'll also have the same number of neutrons, 86, unless there's an isotope. Remember, an isotope means the same number of protons, but different number of neutrons. And we'll look at that in a second, how to calculate that. And even though we already saw it a little while ago. All right, so then you have the chemical symbol. The chemical symbol for radon right here, so let me go ahead and erase this. The chemical symbol for radon is Rn. All right, that is a chemical symbol. All right, and then if you're talking about the chemical name for it is just radon, right? And it's all right here. You can find all of this information on these little squares in the periodic table, right? And then you have the number of neutrons. So the number of neutrons, this is how you'll calculate it. Remember, don't just assume this right here, that you have the same number of protons, electrons, and neutrons, because if you have an isotope, then this will not be the case. So you always want to make sure to calculate atomic mass minus atomic number, right? So atomic mass minus atomic number. And in the case of this right here, this math problem works out to, let me go ahead and punch it in right here. So this is 136.018. Right. So right here, again, if you would have just gone with this and said 86, you would have been wrong. In this case, because it's an isotope, you have 136.018 neutrons. Right. So make sure that you know that. Also, make sure that you know the properties of metals. And so let me bring this up right here. But here's some properties of metals. Just think of any metal that you know, right? Copper, steel, metal, gold. Remember, these right here are shiny. They're just shiny, right? And they're solid at room temperature. Malleable, so it means that they can be hammered flat. And ductile, which means that they can kind of be pulled and stretched into wires, right? That's why copper wiring is so popular. Has a high conductivity, which means it's able to transfer heat or electricity to another object, right? So remember these. These are going to be very important. Also, make sure you know what a nonmetal is and what the characteristics of that are. So, kind of like the opposite of properties of metals, right? So, these are usually going to be, they're not going to be shiny. You look at the sulfur here in this image, especially the big chunks in the top GIF, right? They just rip those out of volcano vents, and that's how they gather sulfur. But you see right there, it's not shiny. These are poor conductors, which means that they don't conduct heat or electricity very well. They're mostly gases at room temperature. Here you see that there are some solids, but they're mostly gases like oxygen, carbon, nitrogen, neon, helium, right? Usually gases at room temperature. But if they are solid, then the solids are brittle, right? It's not hard like a metal. You see here in this bottom GIF that there's actually little chunks breaking off because of how brittle this sulfur is, right? So even if it is solid at room temperature, it's a brittle solid. It's not sturdy like metal.